All right. So this is section 4.6 if you label things. Um, 4.5 is all about sine and cosine. 4.6 is labeled other trig graphs. Okay, so it's all the others. Except we won't go through the sixth one, cotangent. We'll just talk about tangent. We won't worry about cotangent in this class. Okay? So, what do we know about secant and cosecant? Like, what is our basic knowledge? Chris?
Maybe the inverse of cosine and sine.
I'm going to let you pick a new word. I would disagree with you that they are the inverse. They are the reciprocal, okay? Sometimes it's not a big deal to get those two words mixed up, but in trig, they're two very different things. Actually, after our quiz Monday, we'll talk about what an inverse is, okay? Secant and cosecant are the reciprocal functions, okay? Secant is the reciprocal of what? Cosine. Cosecant is the reciprocal of sine, okay? Now, in your pod, please talk to each other about what is a reciprocal. Okay, explaining a reciprocal in basic words, pod 6, what would you say? Flipping the fraction, right? That's when we're thinking about reciprocal, we take a fraction, we flip it, okay? That's about the best way to explain it, okay? We got to flip it, all right? Basically what we're going to do, welcome back, is we're going to take our values on our sine and cosine curve. We're going to figure out what they are, and we're going to flip them to make them fractions, okay? However, we have an issue. Is it possible that sine or cosine can be 0? Sine can be 0, right, at 0, pi, 2 pi. Cosine is 0 at pi over 2, 3 pi over 2. What happens when we try to take the reciprocal of 0? We get an undefined value, okay? If we try to take the reciprocal of 0, we get an undefined value. Now, what is going to happen graphically if we have something that is undefined? We're going to get a vertical asymptote. If you think way back to, was it chapter 2? Okay, when we talked about rational functions, if we divide by 0, we had an undefined value, we put an asymptote there. Okay, same thing happens in trig. If we have an undefined value, we have to represent that with an asymptote. Okay, so your secant and cosecant graphs are going to have asymptotes in them. Okay, so let's go ahead and build those parent functions by just looking at the parent functions of sine and cosine. Okay, go ahead and draw in the sine graph in your notes very lightly, very lightly. And leave a little bit of room in between what you last wrote and the graph. Okay. So we're going to take the parent function of sine, and we're going to create the parent function for cosecant. Okay. And we're actually going to do that anytime we graph. Okay, if I ask you to graph a cosecant curve, I want you to think about what sine would look like and then base everything off of that. Okay? So let's think about this. Right here at 0, the sine value is 0. If we take the reciprocal, what's the cosecant value? Undefined. So we would have an asymptote there at x equals 0. Okay? How about here at pi? The sine of pi is 0. When we take the reciprocal, we get undefined. So we would have an asymptote there at x equals pi. Anytime the sine is 0, we take the reciprocal and get undefined. So at 2 pi, we would also have an asymptote. Okay, so what's happening in between the asymptotes? Okay. Remember, cosecant is the reciprocal. All right. So here, on the sine curve, we have the coordinate pi over 2, 1. The y-coordinate, that's the one we're taking the reciprocal of. What's the reciprocal of 1? 1, okay? So that point actually stays as is. But if we think about like the sine of pi over 6, what's the sine of pi over 6? 1/2, and if we take the reciprocal of 1/2, we would get 2. So like pi over 6, the cosecant would be 2. Same thing over here. The sine of 5 pi over 6 is 1/2. When we take the reciprocal, we get 2. That's going to happen with all of these values to where we get this kind of U shape in between. Okay, and you know that if we have an asymptote, the curve has to approach it. Okay, so this U shape is approaching the asymptotes in between. All right, let's talk about down here. At 3 pi over 2, our sine value is -1. Well, the reciprocal of -1 is -1. That actually gets to stay on the curve. But then the same thing happens. If we take the reciprocal of all of these coordinates, they're going to be below -1 to where we have another kind of U shape in between the curves. Yeah.
So it makes like a cycle of parabolas.
Well, I wouldn't call them parabolas because it's not a polynomial, but yes, we have kind of a cycle of those U shapes. One opens up, the next one opens down, the next one opens up, the next one opens down. Okay, so just like a sine curve, there are 5 things that you would want to label. Okay, you're going to want to label the asymptotes and then the coordinates that create those U's. Okay. Do you think the secant graph is going to look similar? Yes or no? Probably. Sine and cosine have a lot in common. Secant and cosecant are probably going to have a lot in common. So we are going to create the secant parent curve. If you want to go ahead and very lightly draw in cosine so we can figure out what secant will look like. the same thing is going to happen here. Wherever cosine is 0, when we take the reciprocal, we're going to get asymptotes. So for secant, we are, the parent function at least, y equals secant of x, we are going to have asymptotes at x is pi over 2 and x is 3 pi over 2. And then at the places where we change direction, right? I guess that would be the best way to describe. We're going to have those u's, okay? So here at pi negative 1, we would have a u, okay? Here at 2 pi 1, we would have a u. And here at 0, 1, we would have a u. Now, technically, this is one full period. If it bothers you to only draw like half of a u, I don't care if you do that, okay? If it bothers you, but technically, one full period would be this right here. Okay? But if you want to complete the u's on the end, that's not going to bother me, okay? Okay? The good news is, you already know how to graph sine and cosine, and that's what we base our secant and cosecant graphs on. So really what we're going to do when we graph a secant or cosecant graph is we're going to graph the reciprocal and then draw in the asymptotes and use where we need to. Okay? So my hope is that we can get 2 examples done before moving on to the tangent graph. Okay, but I'll keep track of time here. Go ahead and write down this equation right here. Okay. Now, since we are no longer talking about like a wave, right? I would not say that a secant or cosecant graph would have amplitude, okay? But we still need to think about what the amplitude would be of the reciprocal function, okay? So I'm just going to write in that the absolute value of A is 2, and we have a reflection because our A value is negative, okay? The cosecant graph does not have amplitude, but when we think about the sine function, the amplitude would be 2. Okay. The period. Chad, what would the period be?
Just 1, or pi. Well, no, it's pi, so 2.
Okay, so 2 pi. Because it's 2 pi over b, b is 1, we have a period of 2 pi. All right? Our starting point. Our starting point. Eli, what is it? Negative pi over 1, right? Negative pi and then our y value. Negative 2. Okay, so we're going to go about our business making a sine curve, and then we will draw in the cosecant curve. Now, some of you may not want to draw in the sine curve, and that's fine. The sine curve isn't a part of our graph, we're just using it as a reference. So if you do draw in the sine curve like I do up here, we're going to do it very lightly, which is why I'm going to do it in green. Okay? So, just like we did the other day, we have a starting point, negative pi, negative 2. We're going to go up and down what would be our amplitude. I'm going to go ahead. Okay, so if we're starting at negative 2, the top of our frame is where? 0, and the bottom of our frame is at? Negative 4. Okay. We are beginning at negative pi. Our period is 2 pi. Where are we ending? What? Pi. We begin at negative pi. We add 2 pi. We're ending at pi. Okay, this makes it nice, right? What's in the middle of pi and negative pi? 0. And then what's in the middle of 0 and pi? Pi over 2. In the middle of negative pi and 0. Negative pi over 2. So we do have a negative a, and we're talking about the cosecant graph, so very, very lightly, I am going to draw in a negative cosine curve. Okay, like I said, you don't have to draw this if you don't want to, but it makes it easier to see where we have to put everything if you do. Okay, if you want to imagine it, that's fine too. Okay, so now, when we had our cosecant curve, anytime the sine function hit the x-axis, we had asymptotes. Okay, well then what we have is we have a shift, right? We've taken this graph, we've stretched it, shrunk it, whatever we did. We stretched it vertically, and then we shifted it somewhere, right? So those asymptotes are going to shift with it. So anytime we hit this middle dotted line right here, that is where we are going to place our asymptotes. So we have an asymptote here at negative pi, 0, and pi. And then anytime we are changing direction, like here, that's where we're going to draw on our U's. So we still have 5 items that we are labeling. They're just not all points. In this case, we have 3 asymptotes to label and 2 points to label to make up our graph. Okay, so what I drew in red and black, that is the actual cosecant curve. The green could be erased if you really wanted to. Yes.
Like on a test, could you leave it like that, or would you have to erase it?
I am not going to make you erase the sine function, okay? But I would just draw it really lightly, okay? If you want to erase the sine function, go for it. If you don't want to draw it at all, I think you can still figure out where to put things. But it helps get your shape if you need it. Okay? All right. The domain and range. I want you to have a 30-second conversation about the domain and range of this function at your table. Go.
Range so you can't get an asymptote again for
Remember, Nick, this is how you know. All right. Some of you are like, oh, we can switch the domain and range, right? Don't forget, we're not doing inverse yet. We're not doing inverse. We're still on just reciprocal, okay? Let's talk about the range first. What do you think about the range? Where do we have y values?
it's like negative infinity to negative 4, like inclusive, and like big U or whatever.
Okay.
And 0 is inclusive to infinity.
What do you think about Caleb's suggestion? Okay, we have y values from negative 4 and below and from 0 and above. Okay, so it's basically the intervals taking out what we had for the range of like a sine graph, right? The sine graph would have a range of -4 to 0, right? But the cosecant graph is going to have the outside of that. Okay? Domain. Quad 3, you're having a very nice conversation about the domain. What were you talking about with the domain?
So it's just gonna be the asymptotes.
Okay, it can't be the asymptotes, right? And I overheard them talking about like, oh gosh, how would you even write that? I am not going to make you write it, okay? You would have to, I mean, it's all real numbers except the asymptotes, right? But how many asymptotes do we have in this graph if we draw it all? An infinite number of asymptotes. So we would have to get creative with the notation, okay? So we could say all real numbers except pi n. Is every pi. In this case, we have an asymptote. But it would have to be different for each. Right? So I am not going to ask you to describe to me the domain of any secant or cosecant graph, because I know that you know it can't be the asymptotes, and I don't want to make you go through the headache of trying to write it out. Okay, quickly we are going to graph this guy. Go ahead and write it down. And we'll get to tangents. Tiger, what's our A value? 1. The period. Grace W, what would the period be? The period would be pi. 2 pi over b, and b is 2. So the period is pi. The starting point. The x-coordinate of our starting point. Maverick, what would it be? Or how would you find it?
C divided by B, right?
Yep, c divided by b.
So pi over 2 divided by 2.
Okay. Which is pi over 4. Our d value is 2. Should pi over 4 be positive or negative? Negative, because we have a shift to the left. All right. So our starting point is negative pi over 4, 2. Our a value is 1. So our frame is going to stretch up to 3 and down to 1. Raise your hand if you cut in half and then cut in half to find your values. Raise your hand if you add 1/4 of the period 4 times. Okay, so 3 people actually do it total. More hands I saw were for the cut in half. So if we're beginning at negative pi over 4, and our period is pi, where would we end? Yep. Halfway between negative pi over 4 and 3 pi over 4. You add those together to get pi over 2. Cut it in half to get pi over 4. Here's a nice one. What's halfway between negative pi over 4 and pi over 4? Halfway between pi over 4 and 3 pi over 4 would be pi over 2. Add them together to get pi, divide by 2 to get pi over 2. Okay, so very lightly or not at all, we can draw in our cosine curve. Okay. This has been shifted, shrunk, stretched, however you want to describe it. Well, all of those together. So anywhere we've hit this middle line, that is where our asymptotes will be. So in this instance, we have an asymptote at 0, and we have an asymptote at x equals pi over 2. You will have to label those. I'll actually have like a separate space for you to write those out. Okay? Then anywhere we have a change of direction, we will have our u's. Please make sure your u's approach the asymptote and you label the coordinate like you would on the actual curve itself. Okay, the range on this graph. Callie, what would it be? Excellent. Excellent. All right. So back and relax for a moment. We're going to come up with the tangent parent function. Okay? Our tangent parent function. And I'll tell you when I want you to actually draw it. All right? Here's our xy axis. So we'll start here. What is the tangent of 0? 0. We'll go with an easy one. What is the tangent of pi over 4? 1. What is the tangent of pi over 2? At pi over 2, we are undefined, which means on the tangent graph, we would have an asymptote. All right? We'll keep going. What is the tangent of 3 pi over 4? -1. What is the tangent of pi? Tangent of pi is 0. Tangent of 5 pi over 4 would be 1. And then the tangent of 3 pi over 2, there's an asymptote right here, right? Okay, so let's back up over here. If we were at negative pi over 4, what would the tangent be? It would be -1. And if we rotated to negative pi over 2, our tangent would be undefined. Okay? So what is happening is we have like these very similar to the shape of a cubic function, except we're in between asymptotes, right? We have this over and over and over and over and over again. This portion right here is one period, and that's the one that I want you to draw down for the parent function. Couple things I want you to take note of. I said that this is one period. How far does it stretch? Pi. It goes from negative pi over 2 to pi over 2. So the period of a tangent graph is pi. That's different. Okay. Also, does it oscillate between two values? Oscillate means like bounce back and forth. Does it oscillate between two values? No. There is no amplitude in a tangent graph. Don't try to identify one. Okay? But we will use the A value to help us. Okay? So I have given you some steps to graphing a tangent function. That's the blue little sheet I just handed you. Okay? Okay, so first thing we're going to do is we're going to find this starting point. Okay, we do it the same way, C over B comma D. However, in tangent only, the starting point will be in the center of our frame. That is different. The starting point will be in the center of our frame. Okay? We are still going to draw our frame with a vertical spacing of A. We'll still go up A and down A. Okay, but we can't call it the amplitude since it's a tangent graph. All right? Now, we're going to calculate the period by taking pi divided by b, since our pair function has a period of pi instead. All right? Now, when we construct the frame, we're still going to go up and down A, but since our starting point is in the middle of our frame, we need half of the period to the right and half of the period to the left. Okay, so we're going to have to split it up. Okay. And then we'll still make our quarter marks as necessary. All right. What I need you to do is we're going to draw our two different tangent graphs. Okay? Here's what happens. You draw your frame. You are going to put the asymptotes on the edge of your frame. And then you are going to put the coordinates. One is in the middle for your starting point. If it's positive, you're going to put them on the edge of your frame on those quarter marks. Oh, I just like totally lost it there. And then if it's negative, it would just have to go the other way. Okay. Still 5 things to label, but it's 2 asymptotes and 3 coordinates. Okay. All right. So we have 5 minutes left in class. We're going to get through an example. Usually I like to have you guys help me out, but we're just gonna get through it. Okay. Go ahead and write down y equals 2 tangent of x plus 3. Y equals 2 tangent of x plus 3. All right, our A is 2. We are not going to identify it as amplitude, but it will help us with our frame. The period we find by taking pi divided by b. Since b is 1, that means our period is pi. Okay. Our starting point will never change. It is still c over b comma d. There is no c. So our x is 0, and then d is 3. Okay, so our starting point is 0, 3, and it's the middle of our frame. So what we're going to do, I'm going to draw the frame. With this starting point in the center. Okay, so 0, 3 is our starting point. Since we're at a height of 3 and A is 2, that means our frame is going to stretch up to 5 and down to 1. Since our period is pi and our starting point is in the middle, we're going to have to go pi over 2 to the right and pi over 2 to the left. So since our x value is 0, right, we're going to go half of the period to the right, so we'll add pi over 2 to the right side, and we'll subtract pi over 2 to get to the left side. Okay. Alternate method, if you want to cut the period into fourths and add it twice on the right, subtract it twice on the left, that'll get you the same thing. Right? So, no matter what kind of tangent graph we have, the asymptotes go on the edge of your frame, and you will want to label them. So x is negative pi over 2 and x is positive pi over 2. Since we have a positive tangent, then no matter what, our starting point is what we want. But then on the quarter marks, we want our tangent to rise. Okay, and as always, label those points. Okay, now I believe you have 5 problems for your homework this evening. Okay, important that you get through these, guys. Tangent is so much different, you have to practice it. Okay, tomorrow, if you have a device of some kind, please bring it. We're going to play around with Desmos. Okay, basically, it's like a marble. Like, you have to get this marble to hit all of the stars. So you're going to have to, like, transform a sine, cosine, or tangent graph until you can get the marble to get all the stars, okay? So if you have a device, bring it. I will have, like, 10 iPads in here to check out, but that's not enough for everybody. Your phone will probably work. If you have a smaller phone, you might want to use one of my iPads. But we'll probably do it in partners, potentially. So we'll make sure everybody has a device. But if you have one, bring one. And then you will get a problem set tomorrow and your quiz on Monday. Okay? All right. What's the period of tangent? Pi. Forget it.
Could you initials?
Yes.